Hey guys, welcome to this second lesson for the basic programming. This time we will talk about the programming in pseudocode, which means this is not real programming code, but simplified code to make it readable and understandable. And it is obviously programming language independent here. So, the previous lesson we said we're going to use from A to B. Let's call this now the start. Let's open up this a bit. And B will be the end band. All right, B. And this means that for now, this means we going from A to B. So that was what we talked about in the previous lesson, right? All right. By the way, if you want to read out, discuss, or have any questions about this lesson, please join the Discord, which link is below in the description. So let's continue for here. Um, Wait a minute. Yep. If we are here and we want to go from A to B, that means that between this we have to do something in here. So what we can do, and I have made here a nice little output screen, which can be your screen of your computer, or yeah, let's make it that easy for now. Um, we have, for example, let's call it print, which will say something in your output. And we do this in double quotes, and we say like the obvious hello world. If we would run this program, we do this in quotes because defining it as a text, right? And print is what we do now, like we say, output it to our screen. So if we would run this program, then your output here will be hello world. So this is the whole program because it is executing from A to B, from the start to the end, etc. Yep, this makes sense, right? Good. Then we're making it a little bit more difficult because if we first, let's say, have an item which we call a counter. So we just say the counter and counting, we start at 1. By the way, this way of noting it down here is like normal math. Please think about that. In normal math, we say like 2 times 6 is 12. But according to the math rules, you are also allowed, and sometimes for analyzing formulas or something, we even have to turn it around, and then you say 12 is 2 times 6. In programming, you should say like, all right, I am defining that 12 is this outcome, or better said, this definition. We say this has a definition of this, all right? So counter have a definition which is 1. All right, I will try to delete this one. Yep. So if we're not saying we're not printing hello world anymore because we are already advancing in our way of code, we say also not print this or print 1 because print 1 would obviously result in print 1. But what we are doing, we say print counter. You can imagine that the output will still be 1. So it will not be counter or something. It does not. It will just print 1 because here you said counter means 1 and here you say print the counter, which will be 1. Okay, now we're resetting our program, and let's say we have a condition. A condition which is, let's call it while counter is below, smaller than, less than, While counter is below 10, then in that case, we also do print counter, which is like a below part of the while. So you have to imagine that in something like a while with a condition, there is also a start A until an end B. And this will be repetitively, it's going from there. But as it's um, not finished yet because the condition could still be true, it's again executing it from A to B. And as long as it's not, if it's the condition is valid, it will keep repeating this every time from A to B. All right, let's clean up this mess. Keeping this in mind, you will see that this will counter will be 1, but it will keep repeating. In the next cycle, how much will be the counter? Still 1, right? Because we're not counting anything, so it will be going 1, 1, 1. It will constantly execute this print counter um, without this becoming invalidated. So you will have an endless loop. Here, this will like literally endlessly loop with once. You can run it for a year and it will still print 1, 1, 1, 1, 1, 1, 1, 1. So we're not wanting to do this, so we're stopping our program. And after we have printed this 1, we say, all right, we say the counter is now the counter plus 1. We're adding 1. It has to calculate the new counter. We redefine actually the term counter, which is the old counter plus 1. If we would run this, then we have a nice little program will output this. I can show you this all later on, but assume from me that this will just do the work. And as we are also increasing counter now, this thing will be invalidated. Yeah, with after, let's say, how far do we go? It will go to 9. We will never see number 10. Why not? Because if you look at this closely, and this is like following every step, um, like we said in the previous lesson, every step has to be done. So counter becomes 2 again, 2. Counter becomes 3, etc. So counter uh, print 8, counter becomes 9. 9 is still below 10, so we're printing 9. Then we say counter is 9 plus 1 is 10. But then this is not valid anymore. So from that point, we are moving to the next step, which is in our case, the end. So it will stop at 9. So this whole program will do this and not more than this, right? This is what we call a condition. Very important term for later on. But this gives you the condition to do this. Now, all right, we got the idea of looping things and having a condition. We are giving commands, and what is most important, we go from A to B, and also within this part, we go from A to B. From the start to the end, from the start to the end, etc., until the condition becomes invalid. So, if we have this, then we can go to a second thing, which is called reusability. Reusability. This means we can also do something which is being able to call multiple times from any part of your code or which you want. And let's call this a function. This means that a function has a function name plus parameters, possible parameters. Maybe it does, maybe it does not. But in most cases, they have one or more parameters because that will be the way you can use the function more simply. So for the simplicity, we just say we pull parameters between these items, and now we can have again, sorry, this is not start, this, and obviously in here we have things which is also being done there. Um, Step A of function name and step B of function name. And so if we call from our main code, we say, all right, use this, then this is just being ran like this, and then it will um, give you the value or something if that is the thing. Maybe we have a third step here, which is reply. We call this return uh, something, a value, right? So if we now, this makes sense, right? So if you're calling this in your code, like here we said print, but instead of print, we say do function name, do something, then it will probably, hopefully, with your edits or things which you want to do within that, you will get a value back. Let me show how this would look in reality. Um, Next to our from A to B code, so it's not in there for at first. We say like we have a function and we call this square number. Let's say it's square number. And we have a parameter, which is our input for this function. What we will do then, let's do it also like this. Um, if we input a number and we want to have the square of it, then we have mm, a value which is, let's name it squared number, is parameter multiplied by parameter. This might not make any sense for you yet, but I will show it to you soon. And the second step will be, we cannot forget that because we will need it very soon, return squared number. Because this calculated thingy here, we defined it as this is parameter multiplied by parameter. We need this value back. So now we are going back to our main program again here. We start with a counter 1, and um, what we will do is not do counter is counter plus 1, and now we will also switch. We are printing after it. So here we have a thing, let's call it outcome, and we define it as this is square number. This is the function we just created below, and we are adding the counter as the parameter. So now it's becoming difficult, and let me show it to you. It will just do, sorry, this cycle. Yep, we already knew that counter is 1, and while counter is below 10, it will just keep continuing doing this. What it's saying here, we are defining the outcome. Let's also print this and not the counter. All right, sorry, back to the story. This square number, we have we are calling it here, like, all right, I want um, the outcome of square number, which is referring to this which we have defined on another place. And we are sending the parameter, which is in this case the counter. So that one goes there. What we then will see is that this becomes 1. This becomes also 1. 1 multiplied by 1 is 1. So in the first iteration of this beautiful thing, we will have the output of 1. But then it becomes very interesting. So what now will happen is that we have the counter becomes actually nothing because we still have to increase it. Sorry, let's do it like this. So the next run, the counter will be 2 in here, right? That means that this one is again going here, but the parameter here, the counter, is now becoming 2. So we have a 2 here, we have a 2 here. It means that this value becomes a 4. 2 multiplied by 2 is 4, right? And this command here is sending it back to here, and it's set here. So this will result in a 4 as a second counter. Then counter becomes 3, right? 3 um, goes in here. 3 multiplied by 3 will result in a counter which is 9, and the following will be 16, 25, etc. So this is how you can write a simple thing which is reusable with the idea of the parameter. This parameter thing, which is crucial here, this is your input, in this case, the counter, and you do something with it and you return an outcome from this function, and it is given back here to this outcome value. It is shown on screen, and then we are preparing to go back until our condition fails. So now let's see if I can delete a lot of my um, nice arrows and drawings. Let's clean it up a little to be a little bit clear about this. So now we will just delete our beautiful intellectual function here, and we also delete this. And we do not care about printing the outcome anymore. But let's stay in our while, and we will do one more thing to show what could be possible. So we do not have only while, for example, we actually have thousands of commands we can use for these kind of things. These are just your very first interactions with our program. What also is very important is what we call if, because this is another kind of condition, like if counter, which are we are iterating, right? We should still, I'm constantly deleting this, but we keep needing this. If counter is 5, then we want to like, let me do it like this. Um, it still should add, wait, let me do it here, is 5. Print, uh, let's say 5. This will just run. If you run this, then you would see something like if counter is 1, nothing happens because it's just internally iterating this, counting up the counter. Counter is 2, you see nothing. Counter is 3, you see nothing. Counter is 4, you see nothing. And when counter becomes 5, you suddenly see outputting 5. Then it goes to 6, it's showing nothing. 6 not showing, 7 not showing, etc. It will only do something here until the counter becomes 10 here, and then the program is ended because our condition is invalid. So here again you see a pretty nice example about going every time from A to B. You have to think about everything, like you even need to think that we should increase the counter every time, because otherwise we will be stuck forever because we set a condition here. We have many other ways to do this, and for most programming languages there are way more options to do this, um, and also better options, because this way I did it now is not the most used case, but it shows the meanings of it. What also are possible things to just wrap it up for a moment for here, and then we can just go to the next lesson soon, which will be about variables, which is kind of related to what we see here. But let's say there are options which are called for, and this means we are defining in this that the counter is 1, where these are things which are for programmers very useful. We say this is the start. Let's say these are kind of parameters. Start, counter is 1, um, and of, or like while counter is 10, is execute. Let's write it like this. And then on end of every run, counter is counter plus 1. This looks very um, complex, but these kind of notation, as said, this is pseudocode and is not really the way you write it. Um, but if we say print hello, then this will return 10 times, or actually 9 times, because we say it's below 10. It will 9 times print hello. And this, for convenience, this could be normally simply noted down as counter is 1, counter is below 10, counter plus plus. This is the way it's in most um, programming languages noted, like this is the start situation, this is your condition which is kept to be executed, and this is the thing which has to be happening on the end of every loop, which is happening here. So you do not have to do this manually every time or have a line here which does that. This will just make it happen for you. But this all stuff will also come in programming specific languages. And what the point is, we're showing here that we are constantly going from A to B, and also in subparts, in smaller parts, we're going like in the functions or in a while condition or in a if condition, or we're going constantly from A to B, modifying things, showing things, anyway. So there for this in pseudocode, the logics and the systematics of this simple programming basics should be clear here. If not, please just join the Discord. Link are below in the description. Subscribe also on the YouTube. Like this video, and absolutely try to comprehend this. Watch the video for 3 times if you want. Pause it. Make sure it makes sense to you, because this is crucial mind thought to progress in further lessons, if you want to completely understand what is happening. All right, guys, see you in the next lesson. Bye.